Welcome everyone. Today in our science demonstration we are going to be speaking about shadows and light and their relationship that they have within our solar system. As this is a really big topic, let's start by just exploring what you guys already know about this topic so everyone's on the same page and we all understand what we're talking about. So the word light, what do we think might be meant by the word light? Does anyone have any ideas? Yeah, you?
A heat source.
A heat source, yeah, that's good. Light can give off heat, that's right. So, heat. Anything else?
Allows us to see.
Allows us to see. Energy, yes, that's a good one. Energy. So it provides energy. Excellent. We'll come back to that. So we've got a few good ones there. We can add to that later. What about light sources? Now when I say light sources, what do I mean by that?
Provides lights, gives us light in day-to-day life.
Yep, so things that provide light day to day.
Yep.
So if we were saying what provides us with light in day-to-day lives, what examples do you think? Has anyone got any ideas of what examples that could be?
A torch.
A torch, excellent, that's a good one. Yep, any others?
A fire.
A fire, yes, it's a good source of light. And what about when we wake up of a morning and we step outside the house? What's the biggest source of light of all? Not so sure. What about the sun? Does anyone have any ideas on what shadows might be?
They're dark.
Dark, yes. Shadows are dark. That's good. Excellent. Dark. What about, where do we see shadows in day-to-day life? Do we always see them? Whereabouts do we usually see shadows?
Behind a person or object.
Behind a person or object, yeah, that's good. When there's a light source behind, usually?
Yes.
Yes. We are going to move into the demonstration now. So, as we'll be working with electricity and heat, and also with the lights off, we ask you all to stay in your seats and just be very mindful that we're working with a little bit of electricity and heat for your safety. To help you understand a little bit better about shadows and light, what I'll get you to do is you don't need any special lamps for this one at all, just with your classroom lights or whatever, just get your hand and raise it slightly above the table like so. If there's a good ceiling light, about 2 centimetres above the table. Now, you can see this dark outline. It's a very prominent shadow, isn't it? That's what we call the direct shadow, or the actual scientific term for that is the umbra. Okay? Now, see how the umbra is nice and dark? If we slowly pull our hand away from the table, notice how the shadow gets bigger, but it also gets lighter. That's because the shadow now is being cast over a wider area, so it loses some of its darkness, okay? And if we go back down again, it gets nice and dark again. Now this next bit you need to look pretty closely, but it's better if you're doing it at home. If you notice around the outside of the umbra, there's sort of a lighter, more fuzzy shadow. We call that the penumbra, and that's basically the indirect shadow. A solid object that we said, such as this, see how it casts a really dark shadow? This is because the light cannot pass through it, so it casts a dark shadow. Now, what we call that in our scientific terms, which we can write in our books now, is opaque. Okay, that's opaque. Light cannot pass through it. Now, the opposite to opaque is something like this. What I have here is just a thin piece of clear plastic, okay? So we see if we hold that above the light, it almost doesn't cast a shadow at all. The light pretty much all passes through it. Now, what we call that is translucent. So we've got our opaque and we've got our translucent. We're going to now move into the relationship between the Earth, the Sun and the Moon, and the light and shadows that they cast on each other. So this lamp here represents our Sun. A few things we need to understand when we look at this is we've put some cardboard here and some tin foil there to make the light brighter, but in actual fact we know that our Sun is a sphere and it would cast light out at all angles. Another thing we need to understand is that the whole time that the Earth is going around, okay? So it is going around the sun. What's another word for going around, do we know?
Rotate.
Rotate, yeah, or
Orbit.
orbit. Excellent. So it orbits the sun. So that just means that it goes around the whole time, so it orbits. Also, while this is happening, the Earth is tilted. Do we know what that word might be if it's tilted? It's tilted on its
Axes.
axis. Excellent. And this maintains this tilt, okay? That never changes. Now, while this is happening, it's also spinning. So it's rotating, it's orbiting, it's spinning, and it's tilted. So there's a lot of things to remember about this. So let's take an example. The sun is shining. It's shining on one. It only ever shines on one face of the Earth at once. So if it's shining on, say, the Caribbean islands, which are here, what might we see that as? If it's bright and it's shining its light on the Caribbean islands, what could that be?
Daytime.
Daytime. Excellent. So it's daytime, of course. The sun's shining. It must be daytime. So if it only shines on one side of the Earth at a time, what might the other side of the Earth be experiencing? So if this is nice and bright over this side, what might it be over on, let's say, Western Australia at that time?
Nighttime.
Nighttime. Excellent. While the Earth's orbiting the sun, the moon orbits the Earth. So this will introduce our next phenomena, the main thing that we're discussing today. Obviously this is a massive topic, but we're going to focus on this one today, which is the eclipse. Now what do I mean by the word eclipse? And no, I'm not referring to the third Twilight movie. I'm referring to something that happens in space. So what might we be referring to?
Something to do with a shadow that forms.
Something to do with the shadow that forms? Good, because we're talking about shadows, so it might have something to do with the shadow. Okay, so what an eclipse actually means is when something is aligned and it passes through the light of another object. So at certain times, completely random times, all these things are lined up, they're aligned. So the moon will come around and it will line up and block the light between our sun and Earth. We call this eclipse. So we can see the shadow that it casts onto the Earth. So down on Earth, we experience this as an eclipse. Now there's two different types of eclipse. Does anyone know what they might be called? Has anyone heard those terms before?
Solar eclipse.
Solar eclipse, yes, that's one of them. Does anyone know the other one? Well, the other one is a lunar eclipse. I'll speak about that in just a moment. The first is the solar eclipse. So the difference between the two is that the solar eclipse is where the moon passes through the light between the sun and the Earth. So it is eclipsing the sun. So it is a solar eclipse. So that's an easy way to remember it for you guys. So it's a solar eclipse. Now, these are, what happens with these is if we're on Earth, we might experience these, but only a few people will be able to experience the actual eclipse. So we can see here the moon is obviously smaller than the Earth, so it casts a smaller shadow. So the only people that would experience this at a certain time is Madagascar. They would be in the total eclipse. They're in the middle, so they experience it. We can still see this in other countries, but we'll just see it as a shadow passing over the sun. Okay, now the lunar eclipse is the opposite. It is where the Earth is in between the moon and the sun. Now, these ones can be experienced by a lot of different people because the whole night side of the Earth can experience this because the Earth casts a massive shadow. If we're adding a few things to our mind map, so for light we had heat, helps us see, energy. Any other things that we've discovered today about light?
Day and night. Affects day and night.
It affects day and night. Good, excellent. Day and night. Anything else?
Can cause shadows.
Can cause shadows. Yeah, good. So they've got a close relationship there, don't they? Okay. Didn't really add anything to light sources. What about shadows themselves? So we had that they were dark, they were solid. Do you remember some of those terms that we used? Those
Solid is opaque.
opaque. Good. And what was the one we could see through?
Translucent.
Translucent. Good.